funny, sometimes it just defaults to that.
Yeah.
Yeah, people don't always come, so. Go ahead, we're ready, talk to me.
So I need to take the derivative so that I can find the slope at the point 1,5 seconds. And then I would have y prime equals 3x minus 2 in parentheses.
And up to you. One way to say that, like I always find it awkward to say, open parenthesis, 3x minus 2, close parenthesis. Sometimes I get tired of saying 3x minus 2 in parentheses. You can also say, like, quantity 3x minus 2.
Oh.
I've heard that before. Anyway, just different ways to indicate that it should be parenthesized. So, keep going.
Cool. And then I'll have that times the derivative of the top, which would just be
So we take the bottom, and I'm repeating all of this so we can hear it on the video. So take the bottom, multiply by the derivative of the top. Keep going, Lou.
and then minus quantity
There we
2x
go.
plus 3.
See, I'm really, this is one of my personality quirks. I'm always looking for a way to say something with the fewest syllables possible, and that's the quickest.
I remember you told us about
yeah.
like point and values. Smart.
Keep going.
And then that would be times by the derivative of the bottom, which is 3.
And of course, divided by the bottom squared. So.
Yeah.
Keep going.
So then I would just, on the top, multiply that all out, I guess. So then I have 6x minus 4 minus 6x minus 3.
Nicely done.
And then all over the bottom squares.
David?
Hello. Close to getting caught up.
All right. Good work. Good work.
So then, would I just simplify on the top?
Uh-huh.
I would just have negative 13.
You're probably seeing it, but I've seen other people struggle when they see this kind of numerator. And what I try to keep reminding people is this idea that the better and better you are at distinguishing between terms versus factors, the fewer mistakes you'll make. It just really helps. So when I see this, I'm like, oh, 4 terms. So when I have 4 terms, I get to add them however I want. I don't have to think of any order or anything. So I just see 6x, negative 4, negative 6x, negative 9. And I just add them. Because I'm better at addition than I am subtraction.
Negative 13, right?
So negative 13. Keep going, bud.
Okay, so then at this point, would I plug in 1 for x to find the slope? So then I would have 13 over 1.
So in very precise language, what is the negative 13 representing?
It is the tangent slope at the point x equals 1.
And on this curve, whatever that is. So,
Okay.
so I just, same old thing, I can draw the picture I always draw. Got a curve, got a point on that curve. I know full well that this is not what this looks like. I don't really care. Works just fine for this class. And then I'm trying to find an equation for, and then just reminding people that curve's not really a curve. Curve's really a collection of dots. Every dot has an XY pair. This line's not really a line either. It's another collection of dots. They say that the line is tangent to the curve simply because the curve and the line share two things. They share a point. The point 1, 5 is on both the collection of maroon dots, which we call the curve, but the point 1, 5 is also in the collection of dots we call the line. And then the green line has only one slope. It's the same everywhere. Wouldn't matter where I was on, whichever dot I picked on the green, the tangent slope would be the same. Curve has an infinite number of different slopes, but at that point of tangency, the slope is the same for both. So that's how I know, this technically is not the slope of the green line. It's the slope of the curve, because I found it using this equation. However, because that green line is tangent, it is the same slope. That's the connection.
And so now that I have the slope, I think I can just write the equation.
Yes, because it's important to recognize that we're going to encounter all kinds of different problems with all kinds of different equations describing curves. But whenever we describe a line, whether we refer to that line as being a tangent line, or a secant line, or a normal line, or a parallel line, but like any kind of line, when the dots are in a form that forms a linear relationship, we don't have to have some sort of parallel random equation that's different every time. The equation we use is always exactly the same. So that makes creating an equation for a line a lot easier, because it always follows this format.
Okay, so then I have y equals -13. X minus 1 equals c plus 5.
And this is a good place to make sure you're clear on something. You now have on the board 3 key equations which you're going to continually work with throughout the year. So it's crucial that you keep straight the purpose of each. So we've got this pink equation, got this light blue equation up here. So this light blue equation. And down here we've got this green equation. Tell me the purpose of each one, Liv.
Okay, so the blue is to find any xy pair in that function.
And the word I like to use that fits pretty well with all the problems we'll encounter is that's going to find every xy pair on the curve.
Okay, so that's going to find every xy pair on the curve. And then the pink, if you plug in x, you can find the slope. And I guess to be more specific, you can find the slope of whatever x you plug in for that curve.
So that's what's crucial to keep reminding yourself that the blue and the pink both are associated with the curve. The blue finds every xy pair of the curve. The pink will find the tangent slope at any of those xy pairs on the curve.
And then the blue is that one just to find any xy pair on the line?
Because the line again isn't really a line, it's just a bunch of xy pairs. So we've got to have some equation to be able to find them. Because we'd be back to a dilemma I mentioned before, after school, in class. When we look at this curve, this line, the number of xy pairs we're looking at is infinite. So there's no possible way to make a list. so we use equations instead. The equations are a very compact way of making an infinite list.
Okay.
Yeah, see that, when you just reacted, I think that's really cool. I don't think people ever realize that. Like, you use these since about 8th grade, and I don't think hardly anyone ever notices that, like, you thought about how incredible that is, that somebody figured out a way to make a list that is infinitely long, but it's just this little equation. So, anyway, good work. So now what?
So now we just have to find the actual answer.
Correct, because on the written section, this is like you were asking me earlier, on the written section, this is fine. You don't want to go further. But don't go further, just stop. But multiple choice, so I've got to somehow figure out which of the ones they gave me is the same.
Okay, so I'm just gonna multiply the 13 out.
Uh-huh.
So I'll have a negative y equals negative 13x plus 13 plus 5. And all the x's are positive, so I'm gonna move that over to the other side.
Mhm.
So 13x plus 5. Equals 18, and that's E.
There you go. Good work.